Hello and welcome back to my channel. Today on the bench I have my FNIRSI soldering station. No, there's nothing wrong with it. I just want to test some things on it. If you are watching Tony359's channel, then you know about his video with the Bacon BK601 Pro soldering station, the one with the huge leakage on the tip. In that video I posted 2 comments in which I stated my theory about why that leakage is so large, and today I want to test those theories on my soldering station. I'll link Tony's videos up here somewhere and down there in the description. If you haven't watched it, please do. What do I want to test? Well, I want to start with the power supply module itself. Have a look at it, test it under load, use the oscilloscope to see what, if any leakage is on the output between the ground and the earth. And then I want to measure the handle wires resistances and see how much loss could there be on them. Test the leakage on the tip and so on. So let's open it up. The model station is FNIRSI DWS 200. They claim it can supply up to 200 watts on the tip. I did order this soldering station a few months back and it has performed flawlessly. The stated power is there, those 200 watts. So I do recommend it. This is the power supply module, and this is what I want to test first. I can't remove the board from the case without desoldering the wires, and I do not want to do that. This is the power supply module. A simple power supply, but it does the job. It is a flyback power supply, of course. The controller I see, can we see it? It is a CR3842S. A popular controller for flyback supplies. It is a current controlled PWM IC. Anyways, there is not much to see on the supply board. Everything looks okay. I want to test it under load. How do I test it under load? Well, I need to assemble 2 of these modules. This is a torch electronic load. This is the main controller module, and this is one of the auxiliary ones. I have the full 600 watts version, but now I'm using only 2 of them for 300 watts. And I need to assemble them because I haven't gotten to this part yet. Haven't had the time. The modules can be connected in whichever way you need. The connections are universal. Let's say I will do it this way. So no, yes, that way. I will use these tabs as links. ATorch didn't provide them, but I bought them off AliExpress. I will link down below. I do not want to do this. They would be offset. So I use one of these links. They are quite thick, and I'll use one for each connection, hoping it will be okay. Unfortunately, my tabs need some work, so too much work for this video. So I had to connect the modules this way. But when I have the time, I will fix the tabs and I will connect the modules the proper way to lose this offset in height. So I have connected my electronic load and it is set up to 300 watts, and I have set it up to constant power, and I will start at 100 watts and go from there. I have my oscilloscope ground lead connected to my earth connection here, and the probe tip connected to the output ground of the power supply module, because as I said, I want to test the leakage on the output ground, between the output ground and earth. And I do have my thermal camera here to test the power supply module under load to see if it heats up and how much. So let's connect the power supply to mains. And I'll turn it on now. I have my output 24 volts. I did solder these two wires straight onto the pins of this connector because I did not want to short anything. So let's turn on this test. I do have my 100 watts and the output is 24.1. So the power supply regulation is okay. Let's see on 100 watts. Do I have any overheating? The NTC does heat up, but it's normal. That is its job. I'll take some screenshots of the thermal camera and put them on editing on the screen. This is the MOSFET. The primary side MOSFET. Doesn't seem to heat up that much. This is the diode. The output diode is normal to heat up. This is the mains bridge rectifier. Nothing too hot at 100 watts. Let's see on 200 watts, because they say it can handle 200 watts, and I did measure that on my review. I do have my 200 watts and 23.94, 8 amps. Let's see now. Give it a few minutes. This is the primary side, the MOSFET at 200 watts. And this is the NTC. As I said, the NTC is normal to heat up. It is its job. This is the diode on the secondary side. I guess you could find a Schottky diode, one which would heat up less, but I won't bother doing that. 70 degrees are nothing to complain about on the diode. And let's see on the oscilloscope. This is common mode noise. You can ignore it. I have connected my oscilloscope ground lead to the plug earth connection, just because I do not want to use the long earth lead as an antenna. And the probe tip is on the negative output of the power supply's module. And I want to test the power supply with no load first, just to see what kind of leakage there is. And look, I'll take some single shot captures. This is mainly noise, switching noise. And we have 16 millivolts peak to peak on what I think to be the switching waveform. Let's see on 100 watts. Yes, this does seem to be the switching waveform at what, 65 kilohertz. It must be the switching frequency of the power supply. And on 100 watts I have this ripple of 82 millivolts peak to peak. Let's see on 200 watts. So let's say 100 millivolts peak to peak of ripple voltage between the output ground and the earth connection. So this is the power supply's voltage leak. Switching power supplies do have some voltage leak. Back to the station, to the soldering station, and I want to measure the wire resistances, and I have this nifty device. It's an it's a multi-purpose tool. It can also measure small DC resistances, it can measure capacitance, it can measure electrolytic capacitors in circuit, measure their capacitance and their ESR, and much more. So I have set it up to measure DC resistance because I want to measure the resistance of the ground lead first. There doesn't seem to be a separate earth connection to the tip. Not sure if you can see it, but the first pin up is the temperature, then the ID pin, then one J1 pin. Not sure what that is for. Ah, no, that J1 is the notation for the connector. Then P plus and P minus and P plus. Those are the power connections. So the earth to the tip goes through the power ground, and there's this black wire. So let's see what is its resistance. 143 milliohms, 144, 133 milliohms. And what is the tip resistance? 2.8 ohms or thereabouts, with just over 8 amps of peak current on these wires. We should have just over 1 volts of peak voltage drop on the ground lead, and I will measure that with my scope. So let's measure the voltage drop on the handle. I have my oscilloscope probes here. The ground is connected to the earth connection on the main socket, And with this clip, I will connect to the tip. This is what I want to test, the voltage drop on the ground lead. So I will start the soldering station now. This is the switching waveform for the tip when it's at idle. And although the width is very small, still you can see the peaks here. Ignore the switching noise, that is unavoidable. And I do have just over 1 volt peak of voltage drop on the ground lead. I am using a cup of water to cool down the tip, so I am forcing the soldering station to increase the power to the tip. And look, now the power is at 100% and still 1.2 volts. The voltage drop on the wire, the peak voltage drop on the wire is the same. Only the duty cycle of that switching waveform changes. So we do have some voltage drop on the ground lead, and this is unavoidable. As I said in Tony's video on the comment section, the handles cable does present some resistance, and when there is no separate earth connection straight to the tip, that resistance will present itself as a voltage drop between the tip and the earth connection. This is unavoidable, and it is so no matter what power supply uses the soldering station, either a mains power transformer, a 50 or 60 hertz power transformer, or a switching supply. So what we call a voltage leak on the tip is in fact a voltage drop on the handles cable, and it is unavoidable. The leak itself are those 100 millivolts peak-to-peak waveform we have measured in full load on the power supply module output. Is this a problem? Is this voltage drop a problem? Well, I don't think so, because you would need to provide a smaller DC resistance path between this earth connection of the mains IAC socket and the return earth connection for the device you are working on. And most of the times that is impossible. So most of the voltage, the current, will go through the handles cable. I'm guessing there would be some milliamps of current through the device you are working on, but I don't see that being a problem. And those milliamps are just peaks, not average current. Providing a separate earth wire for the tip would only help by disconnecting the power supply output ground from the earth connection. And this is something I do not like to do. So what have we found? Well, any soldering station which does not have a separate earth lead to the tip will have a voltage drop between the tip and the earth connection. And as I said, that separate earth connection to the tip will only help by disconnecting the power supply ground output from the earth connection because if you do not do that, then that separate wire would only share the load the current load, and you would still get some voltage drop, maybe less, but it will still be there. I'm guessing this is the problem for Tony's backbone soldering station. Too high resistance on the cable, on the handles cable. This is why he could measure, even with the multimeter, such a high voltage drop, because as you have seen, that voltage drop is a switching frequency of high frequency, and multimeters do not handle very well those frequencies. This is why I've used my oscilloscope to see better what is there. Finally, I want to test my station's calibration with this tip. This is not an original JBC tip. It is just a straight D tip from AliExpress. I'll link it down below. Why I am doing this? Well, recently I have performed some tests on some leaded solder, and I found that it melted at about 210 degrees C, and that seemed a bit too much for me. So I want to test the calibration. I did the calibration on a genuine JBC tip, but with every tip, I'm guessing you need to perform some calibration because there are some tolerances, some differences, and so on. So I'm using this tool, and let's get into the menu. First, on 100 degrees Celsius, we have what? 140, 141, 142, no, even less. So let's increase it. It doesn't need to be very precise. Let's say this is it. Now 250 degrees. On this end seems fine. Yes, let's leave it at that. And last 350. There we go. Now back to the 150. Let's see if we mess that up. No, it still seems fine. Let's leave it at that. I have set up my soldering station at 185 degrees C. This is the temperature that should melt the leaded solder. So let's see. A bit of overshoot. Why? The calibration seems fine, 252 degrees C compared to 250 on the soldering station. The calibration seems off at 150 degrees. Seems indeed off, so let's fix it. It is more difficult to calibrate at such a low temperature. I do not have low melt solder, the type of solder that melts at below 100 degrees C. This makes it more difficult to make good contact with the temperature sensor. Let's leave it at that. There we go. 184 degrees C. 85. Works for me. So let's see. Does the leaded solder melt? Yes. Yes, it does. Good. How about 180 degrees? It still melts, but more difficult. 175. Not really. So yes, calibration done. I wanted to do this just to be sure about this solder wire. I have recently ordered it from some local online store here in Romania, and when I saw that it would only melt at 110 degrees C on the screen, I thought, this is not leaded solder, right? But as you have seen, it is leaded solder wire. I do not like lead-free solder wire. Sorry, but I hate it. So yes, this is what I have for you today. If you watched it until the end, thank you very much. If you enjoyed it, please give it a thumbs up, subscribe, and all that YouTube stuff. If you want to support me, you can do so by buying super thanks or by becoming a member of the channel. So yeah, until next time, bye.